Hello students. Today is the 6th lecture session, part 1. Topic of the lecture: database systems. In this video, we will cover the following topics. Introduction. History of database management system. Database classification. Relational database tables. Relationships between tables. Skelly. Advantages of DBMS, disadvantage of DBMS. Conclusion. Introduction. Database management systems, DBMS, are used to create databases and manipulate their data. They are a set of language and software tools designed to create, maintain and use a database. Language tools, languages for describing and manipulating data, languages for queries to the database. Software means application programs for processing the data contained in the database. Thus, it is the DBMS that allows you to create databases, update and supplement information, and provide flexible access to data. The DBMS creates on the computer screen a certain environment for the user, DB's interface, and has certain operating modes and a system of commands. History of database management system. Here are the important landmarks from the history. 1960, Charles Bachman designed first DBMS system. 1970, COD introduced IBA's Information Management System IMS. 1976, Peter Chen coined and defined the Entity Relationship Model, also known as the ER model. 1980, Relational Model becomes a widely accepted database component. 1985, Object-Oriented DBMS develops. 1990, Incorporation of Object Orientation in Relational DBMS. 1991, Microsoft ships SSIP Access, a personal DBMS and that displaces all other personal DBMS products. 1995, First Internet Database Applications. 1997, XML applied to database processing. Many vendors begin to integrate XML into DBMS products. Database classification. Depending on the nature of the data, a distinction is made between factual and documentary databases. Factographic databases. Factographic databases contain information related to a specific subject area and presented in a strictly defined format. For example, databases of the institution's personnel, transport systems, scientific data, information about the population, about natural resources, etc. are factual. Documentary databases. Documentary databases are used to store and work with documents. Often these are documents in natural language, monographs, publications in periodicals, texts of legislative acts, etc. Often documentary databases contain video and audio documents. Modern databases are increasingly combining the features of documentary and factual databases. A method of storing data. According to the method of data storage, centralized and distributed databases are distinguished. In centralized databases, all data is stored on one computer, local or network. In distributed databases, parts of the database are stored on many computers connected to each other in a network. Data organizations. Depending on the type of data organization, the following basic models of data presentation in the database are distinguished. Hierarchical, network, relational. The most common of these models is relational. Today, new types of database organization are emerging, usually based on a relational approach. Hierarchical models. In a hierarchical model, data is represented as a tree hierarchical structure. It is a strict subordination of elements, one of which is the main one, the rest are subordinates. This organization of data is convenient for working with information sorted by levels, but for data with complex logical relationships, it is too cumbersome. The graphical representation of the model is a tree. The network model. In the network model, data is organized in the form of an arbitrary graph, that is, the links between elements are arbitrary. It is more flexible, there is no clearly expressed main element in it, there is the possibility of establishing horizontal connections. Its disadvantage is the high complexity of implementation. In addition, a significant drawback of hierarchical and network models is that the data structure is set at the stage of database development and cannot be changed later, when organizing data access.
Relational models.
The relational model is a collection of tables, which are also called relations, hence the name relation. This model was proposed in the 70s of the X century by an employee of Ibn Khaldun. It is based on set theory and mathematical logic. It has been proven that any data structure can be reduced to a tabular form. The advantages of the relational data model are simplicity, flexibility of structure, convenience of computer implementation, and the presence of a theoretical description. Most modern databases for personal computers are relational. The following operations are effectively implemented in a relational database. Sorting data, for example, students alphabetically, sessions by time. Fetching data by groups, for example, all routes by directions, all students by grade. Search for records, for example, search for books by their author, products by name, etc.
Relational database tables.
Structures of the database tables. Each table consists of rows and columns and is designed to store data about objects of the same type. Each row contains information about one specific DD's object, for example, book, employee, product, and each column contains a specific characteristic of this object, for example, last name, title, price. The rows of such a table are called records, the columns are called fields. Each field must have a name that is unique within the table. In different records, the values of individual fields can be repeated. But the table must have a set of fields in which the value is not repeated for any record, it is unique for each record. Such a field is called the key field, key, of the table. By the value of the key field, you can uniquely get the entire table record with this key value. A simple key consists of one field, and a composite key contains several fields. Only one key can be defined in a table, which is called the primary key. For example, this field can be a product code, car number or library card. Any table in a relational database has the following properties. Each element of the table is one data element. All fields, columns in the table are homogeneous, that is, the data in one column is of the same type, number, text, date, etc. Each field has a unique name. There are no identical records, rows in the table. The order of the records in the table can be arbitrary. Each field in the table has a specific type. A type is the set of values that a field can take and the set of operations that can be performed on those values. There are four main types for database fields: character, numeric, Boolean, and date. Character type fields are intended for character sequences, texts, codes, etc. Date fields contain dates of the form day/month/year. Numeric fields can only store numbers. Boolean fields store data that can only take one of two values, yes or no, true or false.
Example 1.
The vehicle information table requires you to store information about vehicle models, horsepower, body color, and time of manufacture. Each car is characterized by its own code. Determine the structure of the table. Solution. The listed data will form the fields of the table. Thus, fields, columns, car code, model, engine power, color, year of manufacture can be defined in the table.
The vehicle code field is key, it uniquely identifies any record in the table.
The types of all fields, except year of issue, are character, year of issue, numeric. The vehicle code field contains text characters and therefore has a character type. The year of issue field does not contain a date, but a number, therefore it is of the numeric type. Table records contain data about specific vehicles.
Example 2.
Define fields and records in the presented customer table. Indicate which field can be key in this table.
Solution. Each column of the table contains some characteristic of the object client.
These columns are table fields: customer number, last name, first name, city, phone. Among all the fields, only the customer number uniquely identifies a specific customer. The last name or first name fields are not suitable for this purpose, since they contain duplicate last names and first names. Even if the proposed table did not contain namesakes, then such a variant could arise later, when adding to the database. Therefore, the last name field cannot uniquely characterize the customer. Provided that each client has its own unique number, the client number field can be a key field in this table. Each row in the table contains information about one object customer, so the rows in the table are records. Relationships between tables. As a rule, a relational database consists of a set of interconnected tables, some of which are master, others are subordinates. Organizing a relationship between tables is called linking or joining tables. Links between tables are established when the database is created. The fields that are used to link tables are called link fields. The link field of the subordinate table is called a foreign key. There are the following types of relationships between tables: one-to-one relationship, one-to-many and many-to-one relationships, a many-to-many relationship. Skelly. What is Skelly? Skelly is the standard language for dealing with relational databases. Skelly can be used to insert, search, update, and delete database records. Skelly can do lots of other operations, including optimizing and maintenance of databases. Skelly stands for Structured Query Language, pronounced as SQL or sometimes as SQL. Relational databases like Nosql Database, Oracle, ICT Skelly Server, Sybase, etc. use ANSI Skelly. How to use Skelly. Skelly code example. Select asterisk from members where age greater than 30. Skelly syntaxes used in different databases are almost similar, though few ODMs use a few different commands and even proprietary Skelly syntaxes. What is Skelly used for? Here are important reasons for using Skelly. It helps users to access data in the ODM system. It helps you to describe the data. It allows you to define the data in a database and manipulate that specific data. With the help of Skelly, you can create and drop databases and tables. Skelly offers you to use the function in a database, create a view, and stored procedure. You can set permissions on tables, procedures, and views. A brief history of Skelly. Here are important landmarks from the history of Skelly. 1970 Drive. Edgar F. Ted Codd described a relational model for databases. 1974 Structured Query Language appeared. 1978 IB released a product called System/R. 1986 IB developed the prototype of a relational database, which is standardized by ANSI. 1989 First ever version launched of Skelly. 1999 Skelly 3 launched with features like triggers, object orientation, etc. Skelly 2003 window functions, XML related features, etc. Skelly 2006 support for XML query language. Skelly 2011 improved support for temporal databases. Types of Skelly statements. Here are 5 types of widely used Skelly queries. Data Definition Language, DDL. Data Manipulation Language, DM. Data Control Language, TKEC. Transaction Control Language, SHIKIKEC. Data Query Language, DOCEC. List of Skelly commands. Here's a list of some of the most commonly used Skelly commands. Create defines the database structure schema. Insert inserts data into the row of a table. Update updates data in a database. Delete removes one or more rows from a table. Select selects the attribute based on the condition described by the where clause. Drop removes tables and databases. Skelly language elements. Here are important elements of Skelly language. Keywords. Each Skelly statement contains single or multiple keywords. Identifiers. Identifiers are names of objects in the database, like user IDs, tables, and columns. Strings. Strings can be either literal strings or expressions with var, char, or char data types. Expressions. Expressions are formed from several elements, like constants, Skelly operators, column names, and subqueries. Search conditions. Conditions are used to select a subset of the rows from a table or used to control statements like an if statement to determine control of flow. Special values. Special values should be used in expressions and as column defaults when building tables. Variables. Sybase IQ supports local variables, global variables, and connection level variables. Comments. Comment is another Skelly element which is used to attach explanatory text to Skelly statements or blocks of statements. The database server does not execute any comment. Null value. Use null, which helps you to specify a value that is unknown, missing, or not applicable. What is a database in Skelly? A database in Skelly server that is made up of a collection of tables that stores a detailed set of structured data. It is a table that contains a collection of rows, referred to as records or tuples, and columns that are also referred to as attributes. Each column in the table is designed to store a specific type of information, for example, names, dates, dollar amounts, and numbers. What is Nosql? When you use a relational database for massive volumes of data, the system starts getting slow in terms of response time. To overcome this, we could scale up our systems by upgrading our existing hardware. The alternative to the above problem would be to distribute our database load on multiple hosts as the load increases. This is known as scaling up.
Nosql Database is non-relational databases that scale out better than relational databases and are designed with web applications in mind.
They do not use Skelly to query the data and do not follow strict schemas like relational models. With Nosql, ACID, atomicity, consistency, isolation, durability, features are not guaranteed always. Nosql is an upcoming category of database management systems. Its main characteristic is its non-adherence to relational database concepts.
Nosql means not only Skelly.
The concept of Nosql databases grew with internet giants such as Google, Facebook, Amazon, etc., who deal with gigantic volumes of data. Advantages of DDMS, disadvantage of DDMS. Advantages of DDMS. DDMS offers a variety of techniques to store and retrieve data.
DDMS serves as an efficient handler to balance the needs of multiple applications using the same data.
Uniform administration procedures for data. Application programmers never exposed to details of data representation and storage. A DDMS uses various powerful functions to store and retrieve data efficiently. Offers data integrity and security.
The DDMS implies integrity constraints to get a high level of protection against prohibited access to data. A DDMS schedules concurrent access to the data in such a manner that only one user can access the same data at a time. Reduced application development time.
Disadvantage of DDMS. DDMS may offer plenty of advantages, but it has certain flaws. Cost of hardware and software of a DDMS is quite high, which increases the budget of your organization. Most database management systems are often complex systems, so the training for users to use the DDMS is required.
In some organizations, all data is integrated into a single database, which can be damaged because of electric failure or database is corrupted on the storage media.
Use of the same program at a time by many users sometimes lead to the loss of some data. DBMS can perform sophisticated calculations.
Conclusion. The database is focused on a specific subject area and is organized around a subset of data.
Database capabilities are useful in areas related to long-term information management, such as digital libraries and data warehouses. Thank you for your attention. Goodbye.